Hello and welcome back. This video covers the Unit 6 test review number 2 on polynomial functions. For question 1, we have this polynomial and it says to list all the possible rational zeros of the function. Now to list all the possible rational zeros, we do P over Q. And P over Q is, P is the factors of the last number, 6, and Q is the factors of the first coefficient, which is 2. So all the factors of 6 that's P, would be plus or minus 6, plus or minus 3, plus or minus 2, and plus or minus 1. And then for Q, all the factors of 2 are plus or minus 2 and plus or minus 1. When we simplify that and come up with all the combinations of fractions, we get plus or minus 6, because 6 divided by 1 is 6, and 6 divided by 2 is 3. Then you'll have 3 divided by 2 is 3 halves, and 3 divided by 1 is 3, but we've already listed that one. Then you have this 2 divided by 1 is 2, and then 2 divided by 2 is 1. And then for the 1 divided by 1 is 1, which we already have, and then 1 divided by 2 is 1 half. So these are all of our possible rational zeros. Now part B says write f of x in factored form. Well, to write in factored form, we need to look at the zeros. So let's find the zeros using our calculator. Here I've graphed the function. And you can see the picture of the graph on the right, and you can see that it crosses the x-axis at -2 and also at +3. Now it crosses the x-axis somewhere between 0 and -1, but we're not sure exactly where that is. So let's use the 0 of -2. So we will use -2 on the outside and do the synthetic process. Our coefficients are 2, -1, -13, and -6. We bring the 2 down and then we multiply and add the rest of the way. So 2 times -2 is -4, minus 1 is -5, times -2 is +10, minus 13 is -3, times -2 is +6, and then minus 6 gives us a remainder of 0. The resulting polynomial would be 2x squared minus 5x minus 3. And I believe we can factor this because 2 multiplied by -3 is -6. And the two numbers that multiply to -6 and add to -5 are -6 and +1. So we can then write this as 2x squared minus 6x plus 1x minus 3. We can then group the first two terms and the last two terms. Then the greatest common factor in that first group is 2x, leaving us with x minus 3. And the greatest common factor in the second group is 1, and that leaves us with x minus 3. So the resulting factors would be x minus 3 times 2x plus 1. And then the factor that comes from the -2, the 0 of -2, is x plus 2. So our three factors up here would be x plus 2, x minus 3, and 2x plus 1. All right, so these are all three of the factors. All right, now for part C, it says find all the zeros. Well, to find all the zeros, we take the factors from part B and set those equal to 0 and find the zeros. So from the x plus 2, we're going to get a 0 of -2. From the x minus 2 or x minus 3 factor, the 0 would be x equals positive 3. And then from the factor of 2x plus 1, the 0 is going to be negative 1/2. So those are our zeros: negative 2, negative 1/2, and positive 3. All right, here's problem 2. Given the graph of g of x, find all the zeros of the function. Show all work for full credit. Well, we can see that the graph crosses the x-axis at negative 3 and also at 4. So we need to decide which one of those we're going to start with. And let's start with positive 4. All right, so we'll put positive 4 on the outside using the synthetic process. 1, negative 3, negative 7, 21, and negative 36 are our coefficients. We bring the 1 down, and 1 times 4 is 4, minus 3 is 1, times 4 is 4, minus 7 is negative 3, times 4 is negative 12, plus 21 is 9, times 4 is 36, and our remainder is 0. Now we have the resulting polynomial of 1, well, it's going to be 1x cubed plus 1x squared minus 3x plus 9, and that cannot be factored. So what we'll need to do is use another 0 from the graph, and the other 0 is negative 3. So we'll use the synthetic process, putting negative 3 on the outside, and then using the coefficients from the previous answer. That's 1, 1, negative 3, and 9. So those are our coefficients. We drop the 1 down. 1 times negative 3 is negative 3, plus 1 is negative 2, times negative 3 is positive 6, minus 3 is 3, times negative 3 is negative 9, and then plus 9 is 0. The coefficients are 1, negative 2, and 3. The resulting polynomial is x squared minus 3x plus 3. Now this cannot be factored because you cannot find a number that would multiply to positive 3 but add up to negative 2. So we will use the quadratic formula. Putting the numbers into the quadratic formula, here's what we have. And then simplifying that is going to be 2 plus or minus the square root of 4 minus 12 all over 2. That's going to simplify to 2 plus or minus the square root of negative 8 all over 2. And then because we're taking the square root of a negative number, the I comes out, and then the 8 is positive. We'll then need to simplify the 8, breaking that down into 4 times 2. And then a 2 can come out of that because the square root of 4 is 2. So now we have 2 plus or minus 2i radical 2 over 2. And now we can reduce by dividing everything by 2 here. And that leaves us with 1 plus or minus I square root of 2. So now we can write our zeros. The negative 3 was from the graph, which we verified by the synthetic process. 4 is also from the graph and also verified. And then these are our 2 imaginary roots that we found here. All right, question 3. Given f of x, find all zeros of the function. Show all work for full credit. Well, so here's our function. We have no idea where the zeros are, so let's graph this. From the graph, we can see where it crosses the x-axis, and it looks like it's crossing the x-axis here at negative 1 and also at positive 1. So zoom in a little bit more on that. Yeah, so negative 1 it crosses and positive 1 it crosses. It crosses in other places too, but we're not sure where those are. So we can choose either negative 1 or positive 1 for our synthetic process. Let's choose negative 1 first. So we begin by putting -1 on the outside, and then all of our coefficients are inside. And here we show the completed synthetic process. We dropped the 1 down. We multiplied 1 times -1 to get -1, plus the 3 is 2, times -1 is -2, minus 2 is -4, times -1 is +4, minus 3 is 1, times -1 is -1, and then plus 1 is 0. Now the resulting polynomial would be x to the third plus 2x squared minus 4x plus 1. And we cannot factor by grouping there because in the first group the ratio is 1 to 2. In the second group the ratio is -4 to 1, so that doesn't match. So what we'll need to do is look at the graph again and find and use another 0. So as we said earlier, we see that it also crosses the x-axis at +1. So let's use +1 again using the synthetic process. So we bring the 1 over here on the outside, and then the coefficients of the polynomial where we left off is 1, 2, -4, and 1. Using the synthetic process, we would drop the 1 down. Multiply 1 times 1 is 1, plus 2 is 3, times 1 is 3, minus 4 is -1, times 1 is -1, and plus 1 is 0. The resulting polynomial would be x squared plus 3x minus 1. This cannot be factored, so then we will find the other zeros using the quadratic formula. All right, now entering the values into the quadratic formula. The quadratic formula says -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And these are the numbers that go in there. Simplifying further, 3 squared is 9. And 4 times 1 is 4, and that's going to be positive. Simplifying further, the radical becomes 13. And then we have -3 plus or minus the square root of 13 all over 2. Those are our other two zeros. So our 4 zeros total are the -1 from here, the +1, and then the -3 minus radical 13 over 2, and -3 plus radical 13 over 2. So 4 zeros altogether. All right, question 4. Give a possible polynomial equation with the lowest degree for the graph. So let's kind of zoom in on the graph. We can see it's crossing the x-axis at -2. So the factor for a 0 of -2 would actually be x plus 2. So we can start by saying f of x equals the factor of x plus 2. We can see that the graph crosses the x-axis at +1, and the factor for +1 would be x minus 1. So we'll add that to the list of factors. And we can also see that the graph crosses the x-axis at +3, and so the factor for that would be x minus 3. So our final equation is this. F of x equals x plus 2 times x minus 1 times x minus 3. And keeping that in factored form is perfectly fine. All right, for question 5. Graph the following functions using your knowledge of zeros and in behavior. So before we graph this, let's list some facts that we know about this graph. First of all, the degree is 1 because x minus 4 is raised to the first power. X plus 1 is also raised to the first power, and then x plus 3 is raised to the second power. So the degree would be 1 plus 1 plus 2, which is 4. We also know that the leading coefficient is negative. We can see that here because of the negative in front. We also know that the end behavior is going down on both ends, and that's because we have an even degree polynomial and the leading coefficient is negative. So we conclude that the graph is going down on the left and down on the right. We also know what the zeros are. The zeros are positive 4 from the x minus 4, negative 1 from the x plus 1, and negative 3. Also, we know that it passes through like a line at x equals negative 1 and x equals 4. That's because the factor of x plus 1 is raised to the first power, and the factor of x minus 4 is also raised to the first power. So that means it must be crossing negative 1 and positive 4 like a line. We also know the turning point. The turning point is going to be at negative 3 because the factor of x plus 3 is raised to the second power. So there must be a turning point at negative 3. Finally, we can sketch the graph. Making sure we include all of these facts, we see that it crosses at negative 3, negative 1, and 4, which it does. Those are the zeros. We've made sure that there was a turning point at negative 3, as you can see there. We've made sure that it passes through at negative 1 and at positive 4. It's passing through here at negative 1, and it's passing through at 4. And we have our end behavior correct. It's going down on the left and it's going down on the right. So this would be a possible graph. All right, and question 6. Use the table to the right to answer the following questions about the function. Part A says, how many roots or zeros are there for this function? Well, in the table we can see 2 of them. We have the 3, 0 and the 8, 0. So we know there's 2 roots there. But because the x is raised to the 4th power, the degree is 4, and therefore we should be expecting 4 zeros. All right, part B, use the table to find all of the zeros and show all work. Well, first, we know that from the table that 3 is a 0. So we use 3 in the synthetic process, and your coefficients are the 1, negative 11, 28, etc. We drop the 1 down. 1 times 3 is 3, minus 11 is negative 8, times 3 is negative 24, plus 28 gives us 4, times 3 is 12, minus 44 is negative 32, times 3 is negative 96, and the remainder is 0. Now I recognize that the resulting polynomial here is going to be x to the third minus 8x squared plus 4x minus 32. And I also recognize that we can factor by grouping because the ratio in the first group is 1 to negative 8. The ratio in the second group is 4 to negative 32, which reduces to 1 to negative 8. So let's factor by grouping. Grouping the first 2 together and the last 2 together. The common factor in the first group is x squared, which leaves us with x minus 8. And the greatest common factor in the second group is 4, which leaves us with x minus 8. The x minus 8 is common, and so you have x minus 8 times the x squared plus 4. The x minus 8 set equal to 0 would give us x equals 8 as a 0. Now we take the x squared plus 4, set that equal to 0. We'll subtract 4 from both sides, and then we're going to take the square root. So we're taking the square root of negative 4, and that means the I is going to come out, so that's going to be x is equal to plus or minus 2i. And then writing all of our zeros would be the positive 3 from the table the 8 that we got here, also from the table, and then the last two imaginary roots. That's negative 2i and positive 2i. Okay, for number 7, it says write a polynomial function f of least degree that has rational coefficients, a leading coefficient of 1, and the given zeros. And the given zeros are this negative 3, 0, and 3i. Well, you must remember that whenever you have imaginary zeros, they always come in pairs. So we're going to expand this list to include the 0 of negative 3i as well. So we make our new list, and it's negative 3, 0, 3i, and also negative 3i. Going from there, we can begin writing our factors. Since negative 3 is a 0, then f of x is going to equal x plus 3. So x plus 3 is one of the factors. Since 0 is a 0, then just x is going to be a factor. Since 3i is a 0, then x minus 3i is a factor. And since negative 3i is a 0, then x plus 3i is a factor. Now we have to make sure that it's written with all rational coefficients. That means we have to multiply these two imaginary roots together to get rid of the i's. So what we need to do is to begin to FOIL. So you're going to FOIL x times x is going to give you this x squared here. And then x times 3i is 3ix. Negative 3i times x is negative 3ix. And then negative 3i times positive 3i is negative 9i squared. That's going to simplify to x squared minus 9i squared, because the 3i and the negative 3ix, they cancel each other out. Now we know that I squared is negative 1, and negative 1 times negative 9 is going to be positive 9. So we have the x squared plus 9 on the end. And our three factors are x plus 3 times x squared plus 9. And I should mention that it said we have a leading coefficient of 1, and that leading coefficient of 1 would be in front here, and that would be understood. All right, for number 8, it says use long division to divide the following polynomials. Now the acronym for long division is DMSB, which is divide, multiply, subtract, and bring down. When you set this up, we need a placeholder in between the x squared and the 3, and that would be 0x. So even in the divisor, it's best to put in your placeholders. So in your divisor on the outside, you'll have x squared plus your placeholder of 0x and then plus 3. On the inside, you have the other dividend part. All right, we'll go ahead and start dividing. When you divide, you always start with the first term in the dividend. So 2x to the 4th will be divided by x squared. And that's going to leave you with 2x squared. And then you're going to multiply 2x squared times your entire divisor. The result is going to be 4x to the 4th plus 0x cubed plus 6x squared. Okay, so 2x to the 4th plus 0x cubed plus 6x squared. The next step, of course, is to draw a line and subtract. So you're going to be subtracting the 2, subtracting the 0, and subtracting the 6. The 2x to the 4th cancel, and then you have negative 4 minus 0 is going to be negative 4 still. That's negative 4x cubed. And then 3 minus 6 is negative 3x squared. We'll go ahead and bring down the next term, which is that negative 5x, and then we start dividing again. So we're going to divide negative 4x to the 3rd by x squared. the result is going to be negative 4x. All right, now we're going to multiply this negative 4x times the entire divisor. So negative 4x times x squared is negative 4x cubed. Negative 4x times 0x is 0x squared. And then negative 4x times 3 is negative 12x. We'll draw a line, and now we're going to subtract. When we subtract the negative, it becomes positive. We're going to be subtracting the 0, and when we subtract the negative 12, that also becomes positive. The result is going to be the 4x cubes canceling out. Negative 3 plus 0 or minus 0 is still going to be negative 3x squared. And then negative 5 plus 12 is going to be positive 7x. Then we'll go ahead and bring down the positive 1. Now we'll start the division over again. So now we're going to be dividing negative 3x squared by x squared. That result is going to be negative 3, which we put at the top. I will multiply negative 3 times the entire divisor. So negative 3 times x squared is going to be negative 3x squared. Negative 3 times 0x is going to be it's just going to be 0x. And then negative 3 times 3 is going to be minus 9 or negative 9. We're going to draw a line, and then we're going to subtract. When we subtract the negative 3, that becomes positive. We're subtracting 0, and also we're subtracting the negative 9, so that becomes positive. The 3x squareds cancel out. 7 minus 0 is still 7, so that would be 7x. And then 1 plus 9 is 10. And at this point, this is going to be our remainder, because you have 7x to the first power, and the divisor has an x squared in it. So your exponent is now, the exponent of 1 is now smaller than the divisor of x squared. So we know we can stop here. And your remainder is going to be 7x plus 10. So our final answer is our quotient up here at the top. That's 2x squared minus 4x minus 3, plus our remainder, which is 7x plus 10, divided by our divisor, and that's x squared plus 3. So this will be our final answer. All right, question 9, 10, and 11. It says determine algebraically whether the given functions are even, odd, or neither. So for number 9, I already have the work. What you need to do is you need to replace the x with negative x, okay? You've got to do this algebraically. You can't just look at the exponents. So if it says algebraically, this is the way you do it. So replace the x, all the x's, with negative x. So that would be 6 times negative x to the 7th minus 4 times negative x to the 3rd plus negative x. Now we know that negative x raised to the 7th power is going to be negative. So you can put the negative in front of the 6. Likewise, negative x to the 3rd is going to be negative. So that negative goes out in front, making the negative 4 positive 4. And then you have the negative x on the end. Now, comparing this answer to the original, you can see that all of the coefficients are the opposite of the original coefficients. So therefore, that this is equal to the negative of the original f of x. And that makes this odd. Okay, so number 10, you have f of x is 9x to the 3rd plus 7x plus 5. And let's show that work. And so here it is. Again, doing it algebraically, you've got to replace all the x's with negative x. And this is the result. And when you raise the negative x to the 3rd power, it becomes negative, making the 9 negative. and then 7 times negative x is negative 7x. But the positive 5 stays positive 5. How does this compare to the original? Well, the 9 is the opposite, the 7x is the opposite, but the 5 is not the opposite. And it's not the same either, so the answer is neither. All right, and here's number 11. So we have the 3x to the 4th minus x squared plus 7, and we're trying to see if it's even, odd, or neither. So we use the same process. We need to replace all of the x's with negative x. When we do that, we have this negative x is going to be raised to the 4th power. That's going to be positive. So that'll be 3 times positive x to the 4th. Likewise, negative x squared is also positive. The negative that's in front of that remains negative, so that's minus x squared, and then we still have the positive 7. Comparing this to the original problem, we see that it is exactly the same. So f of negative x is equal to f of x, and that means this is even. All right, and then these last 4 questions determine visually whether the given functions are even, odd, or neither. Well, this graph right here is not symmetric across the y-axis, and it is not symmetric through the origin either, so this one is neither. Number 13, this graph is not symmetric across the y-axis, and it is not symmetric through the origin, so this is also neither. For number 14, this graph is actually symmetric through the origin. Like this point here passes through the origin and reflects over to this point. This is symmetric through the origin, and therefore this is odd. And for number 15, you can clearly see that this is symmetric across the y-axis, and that makes this one even. All right, that concludes the video on the Unit 6 Test Review Part 2.